Welcome. Today I'll be doing vector equation of a line for problem paper number 5. Just a reminder that the vector equation of a line is r equal a plus lambda m, where a is a point and m is a vector. The first question, we're going to find the vector equation of the line that passes through the position vector and it's parallel to another vector. When we have the vector equation, we will form the parametric equation and the Cartesian equation. Now, the vector equation of a line is r equal a plus lambda m, where a represents the position vector and m represents the vector that it's parallel to. So the position vector that we have here will go in terms of a, and I'm going to write it in column form, but we can also have it in algebraic form. So therefore, we have A, which is the position vector. We are going to go ahead and I'm first going to write it in column form. It can be 2, negative 1, 4. That assists us to easily write the parametric equation. And lambda m will have 1, 1 minus 2. So where we have I plus j minus 2k, I'm writing it in column form. So in other words, it's the same thing as saying r equal 2I minus j plus 4k plus lambda, and then we're going to have the 1, 1 minus 2 as how we have it above, I plus j minus 2k. Now, when we're doing the parametric form, when you have it written in column form, it's easier to write the parametric form. But once you're fluent, it's not necessary. So first, rewriting r in terms of x, y, and z. The first parametric equation I'll have is x equal 2 plus lambda. So that's the first parametric equation. And now, after we have written the first, we go to the center, where this is going to become the second parametric equation, which is y equal minus 1 plus lambda. And then the third parametric equation is z equal 4 minus 2 lambda, and it's minus 2 lambda because we have a negative 2 at the end. So that's why we have minus 2 lambda. So all these three becomes a parametric equation. The third is a Cartesian equation where it's in terms of x, y, and z. So you're making lambda the subject. So in other words, I can have this as x equal 2 plus lambda, and making lambda the subject, we have this as carrying it over. So x minus 2 equal lambda. Now we can also divide by 1 to highlight that that's the coefficient of lambda. So it's the same thing as saying x minus 2 over 1. Now we're going to do the same thing for y equal minus 1 plus lambda. So after we have lambda equal x minus 2 over 1 or x minus 2, whichever one you prefer, we are going to do the same thing for the second parametric equation, where I'm going to have x equal negative 1 plus lambda, and making lambda the subject, I carry over the minus 1, so it becomes plus 1 equal lambda. And then you can leave it like that, or you divide by 1 to see it is y plus 1 over 1. Now, the next one is where we have z equal 4 minus 2 lambda. And we are going to make lambda the subject. So it means the first thing we carry over the 4. So carrying over the 4, so we're going to have z minus 4 equal minus 2 lambda. And then divide both sides by minus 2. So that means you have z minus 4 equal negative 2. So therefore, this represents the Cartesian equation where we have lambda equal x minus 2 over 1, y plus 1 over 1, and equal x minus 4 over negative 2. Now the next one, we want to write down a Cartesian equation of the line whose vector equation is in the form. So that's it, in the form a plus lambda m. So we have the position vector and we have the vector that is parallel. Now, since we want the Cartesian equation, it's easy to just put it in column form and then go ahead to get the parametric equation. Then we go proceed to get the Cartesian equation. So after having it in column form, the parametric equation would be that we replace r to be x, y, and z. So that means we will have the first Cartesian to be x equal 1 plus lambda. The second would be y equal minus 5 plus 3 lambda. And then the third would be z equal 2 plus lambda. Once we have that, then we can proceed to write the Cartesian, where the Cartesian equation would have x equal 1 plus lambda. Care about the 1, so we have x minus 1 equal lambda. And then the next one, I would have y equal minus 5 plus 3 lambda. And we have to make lambda the subject. So therefore, we will carry over minus 5. So we'd have plus 5. So it's y plus 5 equals 3 lambda. And then divide both sides by 3. So therefore, we have lambda equal y plus 5 over 3. Now, after we do that, we're going to do the same thing for z equal 2 plus lambda. So what we're going to have is carry over the 2. So we have z minus 2 equal lambda. That's what we're going to do. So we carry over the 2. So you have z minus 2 equal lambda. And you equate all of these to be equal. So therefore you have x minus 1 equal y plus 5 over 3, and then you have z minus 2. And it's equal to lambda. That's it. The next one, you have to write the Cartesian equation, but we have to group. You're not see the position and the parallel vector, so we have to first expand and simplify. So expanding this bracket, will have 3j minus 2 lambda j. Expanding here, you'll have 3k plus lambda k. And if you realized here, we have to group the I, j, and k together, while the ones with the lambda you group together. So that's what's happening here. So we have the ones that don't have lambda together, that would represent the position vector, and the one that has lambda, you're going to group it together in the end, because that's going to be the parallel vector. Now I'm going to factor out lambda in the last part. So I'm going to have I plus 3j plus 3k, and then factoring out lambda, you'd have plus lambda being factored out. So you have minus 2j plus k remaining, and that represents the parallel vector. So now we can create the parametric equation, and then we are going to create the Cartesian equation. So therefore, I have it in column form x, y, z, and then this is 1, 3, 3 plus lambda. Then because we don't have any I, 0 in that position, then minus 2, and then 1. So therefore, we have x equal 1, and you can write plus 0 lambda if you want to. It's not incorrect if you do that to assist you when you're doing the Cartesian equation. And then the second one, you're going to take the second row, which represents y. So we have y equals 3 minus 2 lambda. And then the third one will have z equal 3 plus lambda. Now, having this, we can now create the Cartesian equation, and it will be x minus 1, because when you have x equal 1, you have to carry it over. So it become x minus 1, and then if you realize I have the 0 lambda, that assists you better to know that it's going to be divided by 0. So it's x minus 1 over 0 to say that there is no lambda. If you just have x minus 1, then you're saying there's a 1 lambda, and that's not correct. The next one we have y equals 3 minus 2 lambda. And what we're going to do is the same thing as before, where we have to make lambda the subject. So the first thing first, we carry the 3 over. So we have y minus 3, and then divide by minus 2, since we want to make lambda be by itself. And after we divide it by minus 2, that cancels, so lambda equal y minus 3 over 2, well, over negative 2. Now the last one we have z equal 3 plus lambda. So we're going to make lambda the subject, so we carry the 3 over the equal sign. So we're going to have z minus 3 equal lambda, and it's the same as you saying z minus 3 over 1. So note the difference. Z minus 3 over 1 is different from z minus 1 over 0. If you don't have a lambda, we have to say over 0, but it's okay for the next one to not have over 1. So this is the Cartesian equation. Now the next one, we have to write down a vector equation of the line whose Cartesian equation is the following. So what we can do, we can depict the position vector, we can depict the parallel vector. For the parallel vector, it's the numbers that's in the denominator. So therefore it's going to be 2, 3, and 2. And then for here, the x minus 3, just equate it equal to 0 and solve for x, and that will give you the position vector. So carrying that over, you have x equal 3, and carrying over the plus 1 over the equal sign. So equate it equal to 0 and carry it over the equal sign. So y equal negative 1. And by the looks of it, you should be saying that z equal 4 after equating it equals 0. So therefore, the position vector is 3, negative 1, and 4. And that's a vector equation which we can write in algebraic form. R equals 3i minus j plus 4k. And you have the next part, which is the parallel vector, which is 2i plus 3j plus 2k. For the next one, we need to write it in the form r equal a plus lambda m. And as you can see, it's different. It looks different from the previous one. Just remember, if you have y or even y plus 1, it's over 1. So we can already find m. M will be the numbers in the denominator. So we'll have lambda, and then we have 2, 1, 3 represents the parallel vector coordinates. The next one, now we have x, so that means x is going to be equal to 0, since we just have x by itself. And the same thing for y. But the z plus 1 now would equate it to be equal to 0 to get negative 1. So therefore you can write this in the algebraic form. Now lastly, I'm going to do the vector equation of this, and then you can do the Cartesian. When you get 2 points, you have to find the position vector, and that will give you the vector that's parallel. And what we have to do is find AB, or you could find BA, but you have to find the vector. So I'm going to find AB, where AB is equal to B minus A. Or some person will say AO plus OB. Now because I'm doing B minus A, I just go ahead and write B coordinates minus A coordinates and find the answer. Where the answer for this, subtracting the vectors, I will have minus 2. So 1 minus 3, that's how I got minus 2. Minus 1 minus 4, that's negative 5. And 6, negative and negative positive, so 6 plus 7 is 12. So therefore, R is equal to, now for A, I could have used the A coordinates or the B. It doesn't matter because both of them are position vectors. So I can have the 3, 4, negative 7, or 1, negative 1, 6, whichever one you decide. And for M, it's going to be minus 2, minus 5, and 12. And that represents the vector that's parallel. Now, I want you to go ahead and write the Cartesian equation and the parametric equation, where it's the same thing as what we were doing in the video. So use this time to do that and write in the chat what is your result, and we will discuss. Thanks for watching. Don't forget to like and subscribe to my channel. Have a great day.